Okay, we're going to go through some of the important aspects of linear programming, just the standard uh, maximization and then the minimization problem from the text. First one is our maximization. We've got two constraints, carpentry and painting, and two variables, tables and chairs. So product tables, product chairs. What is constraining us from making a million of these, and that is our carpentry time and our painting varnishing time. We make $70 for every table and $50 on every chair we produce. And for carpentry, notice how it goes across the product line. These have to be linear. So for carpentry, it takes 4 hours to produce a table and 3 hours to produce a chair. And we're maximizing here rather than minimizing. So we're maximizing for our profit. And the most amount of carpentry time we have is 240 hours. Painting time takes us 2 hours to paint a table and 1 hour to paint a chair. And the total time we have available is 100 hours. We basically got it all set up. Maximization problem, our two constraints always across the what would this be? The y-axis and the then tables and chairs. Actually, not an axis, but there we are. And I can solve it. I click on solve, and let's go down to the linear programming results. The original problem with answers is the best way to do that. And you can see with my products, my constraints, I should make 30 tables and 40 chairs for a total profit of $4,100. That really is the answer to this bivariate regression. The other thing we want to take just a real quick look at is the graph, and you can see it right here. Let me pull that down a little bit. But you can see our graph here with our tables. If we make no chairs at all, we can make as many as 50 tables. If we make no tables at all, we can make as many as 80 chairs. And of course, our objective function, our most optimal production spot is 30 tables and 40 chairs for a total profit of, you can see it right there, $4,100. Okay, let's go quickly to the minimization problem. Exit, file, whoops. Okay, open. Sure, save it or no, let's not do that. File, close, save it, no. Um, the other one is in the book is the Holiday Turkey Ranch. And I'll just do that real quick. File, new. On this one, as you'll recall from the textbook, we've got three constraints, three ingredients that have to be met for our turkeys, and two browns, or two brands, brand one and brand two of this turkey feed. By the way, this is referred to as a diet problem, but I think that's it. So we've got two variables, two brands, and three constraints that are, constraining us. So I click OK, and we've got it right there. Okay, brand one is our first, let's say, bag of turkey feed, and brand two is our second bag of different turkey feed. By the way, this is a minimization problem because we're going to try to minimize costs rather than maximize profit. And we've got ingredient A, we've got ingredient B, and we've got ingredient C. That's not no good. Ah. Oh my goodness, this is terrible. Ingredient C, who cares? Okay, for our costs, it costs us 2 cents for every ounce. And again, the directions are in the text, but it costs us 2 cents for every ounce uh, of brand one, and 3 cents for brand two for every ounce. And ingredient A, the minimum monthly requirements per turkey for ingredient A is 5 ounces. For brand 2, it has 10 ounces. And it's, of course, less than, greater than. It's got to be less than, or I'm sorry, actually, it's got to be greater than the total monthly requirement of 90 ounces. For ingredient B, brand 1 has 4 ounces. Brand 2 has 3 ounces. And it's got to be greater than or equal to the total monthly requirement, which is 48 ounces. And then lastly, ingredient C. Brand 1 has 0.5 ounces. There's none of ingredient C in brand 2, and the minimum requirement is 1.5. Okay, just double checking it, but this seems to be the linear program. Let's see if I did it right. Okay, go down to original problem. Okay, let me see. Did I make a mistake on this one? I must have. Yeah, of course, right at the end. Let's see where I made my mistake. 5 and 10. 4 and 3. 0.5 and 0. And our solution is 3 and 12. But it should be 8.4 and 4.8 ounces. So I do seem to have a problem with it. Where it is, I'm not quite sure. Ah, there it is. I missed that. You guys probably saw it, but I didn't. I missed that. It's got to be greater than 1.5. I solve it, go back, and there's the correct answer. Again, tedious, easy to make small mistakes, but again, fishing through to find out the correct answer. And it also is worthwhile, since we do have a bivariate, that we can go to the graph. And with the graph, notice that the feasible region here is on the outside rather than on the inside, where you see a maximization problem. And that's because you're trying to minimize costs overall. The last thing that I would like to do is just go back to the window. And so you can see that given our two products and our constraints, we should give our turkeys 8.4 ounces of brand 1 and 4.8 ounces of brand 2 at a total cost of 32 cents, 32 cents if you round up, of turkey feed. Thank you very much for your attention here.